want to double check. If not, look at your calendar so we can talk about important dates so you can keep these in mind. We just finished our Unit 7 tests. Those of you that finished, I got those back to you. I have not put those in yet, so if you're looking at what your grade is, that should be going in either today or tomorrow, and then I'll send out progress reports as that will be your final grade unless you retake, turn in missing Khan Academy's, finish that test. So you will see that you'll have Khan Academy quizzes due really just on today's lesson that's due next week. So make sure you get those done. That'll be the last thing to do before spring break, but you could easily get that done like today, tomorrow, this week. We are going to be doing lessons between now and next Tuesday. Next Thursday is your flex day, which is also the last day I'm accepting retakes, retake work, 4 retakes, missing work, to include the Unit 7 tests. So that is the absolute last day to do the Unit 7 tests, retake it, whatever. So if you don't finish it, you don't get a chance to retake it. So keep that in mind. Come see me in the mornings and afternoons. If you have a free period off, or maybe your class isn't doing anything or has a flex day, ask your teacher if you can come see me. So when we come back from spring break, we're going to continue this unit. You'll have more Khan Academy quizzes. Your next flex day in April will be the 19th, which will be your review flex day before your quiz and your tests. This upcoming Khan Academy will be on the next quarter, so keep that in mind. It'll be the first grades in the next quarter. Test is the last grade in this quarter, and then that's it. What questions do we have on any of that? So some of you have a bunch of tests that you said you wanted to retake, but I haven't seen you before after school, so you need to come see me as soon as possible to get this stuff done. Otherwise, it'll be next Thursday, and you'll still have Delta Math, Khan Academy, and test corrections to do, and won't have enough time to do it. So keep that in mind. We are getting closer to the end. We have this unit and 2 more, but the last one won't be tested. It'll be on the final. We'll talk more about the final later, not right now. But I think you'll like the next unit more than this one. But this unit is all about transformation, so it's going to touch on some of the stuff we were talking about in quadratics and build on it more. This will be somewhat familiar because we've talked about notation, domain and range, throughout shark bites, throughout warm-ups, on the quadratic stuff, and then as well as notation when we were doing inequalities. So we're going to start on this page. Everyone should have this in front of them. So this objective is, can you write notation both ways? I'll talk about the 2 different ways. One is interval notation. The other one is set builder notation. Can you write it in both ways? Can you find the domain and range and different intervals of specific graphs? So we'll go through interval notation first, and then switch to set builder notation, and then switch to the back. So here, you have a bunch of things in set builder notation. It looks like inequalities, which they're the same thing. Your goal is to write them as interval notation, so if you want to write these notes somewhere where you have space, So you remember that strictly greater than, strictly less than have parentheses. Greater than or equal to, less than or equal to have brackets. And if we are going to infinity, negative or positive, that will always have parentheses. So some of our answers could be mixed, could have parentheses and brackets, some could not, it depends. So for the first one, if it says x is greater than negative 3, we're going to start at negative 3 and it's going to keep going to the right. So where would it end if it keeps going to the right? Say that again. Not negative, because that would be to the left if it keeps going to the right. Positive infinity. So it's going to start at negative 3. This is open or strictly greater than, so it's going to start at negative 3 with a parenthesis and go to positive infinity. And that would be our interval notation for that one. If I were to draw this on a number line, so you don't have to do this, but you can. It would have an open circle going to the right, and it's going to keep going to the positives, keep going past 100, past 1,000. It doesn't have a stopping point. So towards positive infinity. The next one, x is less than 8. So that's where it would start, negative infinity, so parentheses, negative infinity, and it ends at 8 with a parenthesis or bracket. That looks like a bracket. So then the next one, x is less than or equal to 2. Where does this start? Negative infinity. This is going to keep going to the left. So that one's going to have a parenthesis, even though it's less than or equal to. Where does it stop? 2, and that would have a fraction. So this would be a case where it's mixed. Questions so far? What would the next one be? Correct. So we'll start at 0, it's closed, or it has the greater than or equal to, so bracket. It's going to keep going to positive infinity, so parentheses. Look at these remaining ones. See which others you want to see, do go over, have questions about. There aren't any here, but I'm just going to make up a couple of examples. If you had one that said -5 less than x less than or equal to 6, sure. It's going to be between those two numbers. It's going to start at -5, it's going to end at 6, but how would we write it? Would they have brackets? Would they have parentheses? Would it be mixed? it would be mixed. So the -5 would have what? Parentheses. And the 6 would have brackets. So in this case, even though it says less than, that doesn't really mean anything. You are just focusing on, does it have the equal to or not, to see, does it have the parentheses, does it have the bracket. Do one more. So let's say it was switched. Let's say I had -5 less than or equal to x less than 6. How to write that then? They could also both be the same, so both be parentheses, both be brackets. If they were both less than or both less than or equal to, it depends. Questions on those? So if I change this to strictly less than, it would both be parentheses, correct? Okay, let's look at the set builder section then. So now it's switched. Now these are in interval notation, and we have to write them as set builder notation. So let's start with this first one. It's between two numbers. So how would we write it? Think about the examples we were just doing, the ones I made up. Less than 4. So the sign's always going to be less than. It's just the way it's written when it's between two numbers. But yes, it would be written like that. Oh. No parentheses. Because we're doing it the other way. -infinity to 5. How would we write that? Because it starts at -infinity, so it has to be everything below 5. So x is less than 5. That's it. We'll do a few of these. How would we write the next one? Let's see. There was a question I wasn't sure. X less than 2. So it's kind of connected. The next one. The next one. So this will be similar to the other one that had infinity. So yeah, we're going to start with x. If it goes to positive infinity, is that above 8 or less than 8? Above 8. So that would be greater than or greater than or less than? Greater than. And then because it's a bracket, would that be greater than or equal to or just greater than? Greater than. This one's weird because the set builder notation is written a certain way. So I'm just going to give that one to you. This reads x is an element of all real numbers. It just means all real numbers from -infinity to positive infinity. Is what that means. All the decimals, fractions, negatives, everything. Trying to see any others we haven't done. jump to this 3, 5. How would you write that one? It'll be similar to the ones with 2 numbers, but we have to look at the sign. You can start.
Greater than or equal to 5.
Less than or equal to 5. Always less than or less than or equal to. Besides when it's infinity. So when it's between 2 numbers, it's always less than or equal to. Okay. Of those remaining, do we have any others we want to see, go over, have questions about? Not go on to the next page. So this is where we're actually going to use those intervals. Finding domain, finding a range where things are increasing, decreasing, and constant. So I'm going to be doing these, drawing the ceiling / roof / walls, and I'm going to explain what that means. If that helps you, also do that, because it may help you see it. So with this first one, the ceiling would be the highest point, if there are points. If there are arrows, you don't have a ceiling. So you may want to outline that these have arrows, not points. So the ceiling of this, we don't have one because it's going to keep going up and up and up. Or the roof, same thing. It doesn't say this, but it should also say floor. The floor of this would be the lowest point. It does not go past this, so I'm going to draw a line there. Then your walls would be, does it stop at a certain point, looking left to right? And it's weird because of your arrows. You have to think about this like it keeps going up and out. So it doesn't really have a place to stop because it's going to keep going out. And same thing with this one. It's going to keep going up and out. So again, it doesn't have a place to stop, so we don't have walls. Whether you do this in this order is up to you. I am going to highlight the x-axis because it's helpful. If you need or want highlighters, I do have some back there. So the range for this would be the easiest to find, and then we'll talk about some of the others. So range, we're looking lowest to highest. What is the lowest point?
-3.
-2, yes. And then what's the highest? Positive infinity. So then we can write it as one of the intervals, either as x is greater than, sorry, not x, y. Y is greater than or equal to, because it's a closed point, -2, or -2 bracket to infinity. You don't have to write both, but you should be able to write both. Okay, we'll talk about the domain first and then talk about everything else. So because this keeps going left and this is going to keep doing that towards negative infinity, and this keeps going right towards positive infinity, what would your domain be? So in set builder notation, that would be your x, the weird e, and the weird r, or negative infinity to positive infinity, either or. Now, the increasing, decreasing constant, that's where it gets a little different. So for increasing, you're comparing your x and y values. Think about it like as your x values keep going up, as you're looking to the right, so 1, 2, 3, 4, 5, as your x values keep going up, where are your y values also going up? So on this, your x values are going up everywhere, but your y values are only going up here from 3 on. So that's going to be the interval we choose to write for increasing. But when we write it, we'll write it as x. So x is greater than or equal to 3 or 3 to infinity. Before we do decreasing, what questions do we have on that? So then decreasing is going to be opposite. It's going to be as your x values keep moving forward or going up, where are your y values going down? And even though this arrow is going up, you have to read it left to right. As I'm reading this left to right, my y values start at 4, then go to 3, 2, 1 is going down. So you kind of have to read the graph a different way. So that means wherever it starts at negative infinity, it's going to keep decreasing until it gets to 3. So x is less than or equal to 3, or negative infinity to 3. What's nice about your increasing, decreasing constant is that these should all connect. Where one stops, the other should start, and so on and so forth. If my decreasing is everything from negative infinity to 3, and my increasing is from 3 to infinity, there's no room to be constant, because that takes care of everything. So there is no constant for this one. I think there. What questions do we have on this so far? Yes. So even though domain is x, range is y values, you're looking at just the y values, and increasing through constant is comparing the two. The only one that will use y is range, because you're looking lowest to highest. It's y values. The second graph is kind of, I was going to say thin, but that's not the word I was going to say. You can't really see it, so if you want to outline it, you can do that. There are arrows at the bottom. And there's like a small little arrow. So let's draw in ceilings, walls, floors, all of those things. Does this have a highest point? Yes. On the x-axis, does it have a lowest point? No. The arrows means it's going to keep going. The arrows also means it's going to keep going out, slightly down and right, and slightly down and left. So it's going to keep going out in both directions so it doesn't have walls. I'm not highlighting the x-axis in this one because we kind of already did that. So starting with range, your lowest point would be what? That's your highest. Negative infinity. And your highest is 0. So you can write it either way. I'm going to continue writing it both. So would that be less than or greater than 0? So less than or equal to 0, or start at negative infinity and go to 0. What would our domain be? And this should look familiar because we talked about quadratics and how that will never change. For the domain, if it's all real numbers. If the range was all real numbers, we would just change it to y instead. We'll do an example like that. Alright, so increasing. When your x's keep going left to right, up, where are your y values going up also? So there are numbers here. So let me rephrase my question. Between when x is 0 and 1, are the y values going up or down? Up. So as you're reading it left to right, your y values keep going up. So that would be where you're increasing. It would start somewhere at negative infinity, and you have to imagine that part, and it would stop at, I guess it's halfway between, so 1.5. So x is less than or equal to 1.5, or from negative infinity to 1.5. So then where would this decrease? Where are your y values going down as your x's keep going up? 1.5, sure, where? Not negative. So even though this is going down, your y values are going down, your x's keep moving forward. So that's where it gets difficult, because we have to keep remembering we're comparing to x's, not y's. But we are going down here. So it would be the opposite of this. X is greater than or equal to 1.5, or start at 1.5, go to infinity. And then again, because this kind of covers from negative infinity to 1.5, 1.5 to infinity, there's no room to be constant. Questions so far? It could be whatever decimal. I'm not sure. I just know this arrow was like in the middle between 1 and 2, so I just picked 1 for that. Alright, so we're going to do this next one, but then we're going to skip the one after that and then go to some of the other ones. Okay, so floor, this has arrows. So if this keeps going slightly down, is there a lowest point? No. If this keeps going slightly up, is there a highest point? No. But it does have a wall. This stops here, it does not go past that point. But to the right, it keeps going. So that side will not have a wall. So then looking at our range, what is our lowest point? That would be our highest point. Not negative 5 because the arrows. Negative infinity. So it's going to go to negative infinity, then positive infinity. So your range is now all numbers. So that's when we would switch it. Instead of the x being that, the y would be that. Now for our domain, reading left to right, our furthest point to the left or our wall is at where? Mm-hmm. And then where is our furthest point to the right? How far does it go? Infinity. So that would be from negative 4 to infinity, or x is greater than or equal to negative 4. Increasing. As we're looking at, as our x's keep going up, where are our y values also going up? Does that happen here? As x's keep going up, are the y values keep going up? Yes. So that would be from negative 4 to infinity. This one is a weird case because, one, this is not a function, but it's also decreasing at the same place because of the way the function looks. We can't say it's doing the opposite because it doesn't go to the left of negative 4 at all. Questions on this one before we move on? These values are going up. The y values are going up as x's are going up. But as your x's keep going up, your y values are going down here. They just happen to fall on the same interval. Right, let's do, I'll let you guys choose. This one or this one? The first one, okay. So do take notice that these are points at the end of this. This one has a point and this one's an open circle. So it's not talking about domain and range, but you can still do that for extra practice. I am going to highlight our x-axis. So we're looking for, as our x value keeps going up, where does our y value also keep going up? So does that happen here? No. The y value is staying the same. Does that happen here? Yes. As your x values keep going up, your y value goes up. So from that line, from that point on, it'll be increasing. So from negative 2 to infinity, or greater than or equal to negative 2. Now before we talk about constant, do we have anywhere where the x value keeps going up but the y value is going down? No. So there is no decreasing for this one. But there is a constant. So this would be where your x values keep going up, but your y value stays the same. And that's going to be starting at negative infinity up to this point. So everything less than. they still connect, even though we skipped over decreasing. From negative infinity to -2, it'll be constant. So like if I could zoom out of this, you would see that it keeps being constant. And then at -2, it starts to go up. And it's increasing. If I could zoom out, you would also see. Excuse me. What questions do you have on that? So, you don't have to do these, but these are problems that I saw that would be good practice. In the remaining pages, there are different things that each one is talking about. Domain and range is the first 3 pages, first 4 pages. Then the 5th page is increasing and decreasing. So if you would like to practice any of those specific ones, you can work on that. You could try the Khan Academy that's due next week, practice that. If you need to finish the test and want to do that, you can come see me and do that. But use this time wisely, practice, Khan Academy, let me know if you have questions, come do your test.